Welcome, everyone. Thank you for joining us today for the Roll Stackable Battery Communication Protocol and Inverter Connectivity webinar. Just a few quick notes before we get started. During the webinar, all attendees will be muted for best audio quality. If you have any questions throughout the presentation, feel free to use the Q&A button at the bottom of your screen to type in your questions. These will be monitored. It's my pleasure to introduce today's presenter, Jeff Miles. Jeff is the marketing manager and product support at Rolls Battery and has been working with Surrett since 2009. Welcome, Jeff, and over to you.
Great. Thank you very much, Tatum. Welcome, everyone. Today, we're going to be doing essentially an overview of our stackable ESS solution and talking a bit about, obviously, the connectivity of that battery with a variety of different inverters. One thing that we have done in-house with the development of this product is to complete inverter protocol setup, testing in-house, and also to create some manuals that will guide you through the process of programming the inverter and ensuring that the connection is set up for closed loop communication. So we'll be walking through some of those steps and how to actually assign that protocol into the battery, which is very easy, and they have a couple of different options to be able to do that. So we'll walk through that and explain, some of the features that are included, and also to talk about a bit about the troubleshooting that may arise if you run into a problem with connectivity. Sorry. There we go. So the first thing that I wanted to go through was essentially talking about the UL certification on this product. So when this product was tested, it was tested to UL 9540 Edition 3, which is a DC ESS pathway. What that means is this product is not tied to a specific inverter for pairing as far as residential application. And so that restriction is no longer required, which you would see in Edition 1 and Edition 2. This allows a lot more flexibility with connecting to other inverters. And so any UL 1741 certified inverter will be compatible with these units and also will be compliant with the regulations for residential energy storage. So this particular unit, the S48100 LFP Stack LV, is a modular stackable ESS solution. The modules are each 51.2 volt, compatible with 48 volt system configuration. They're each 100 amp hour capacity, and you can stack up to 8 of these units together in one stack for essentially a 40 kilowatt hour system. The units have been designed with all of the connections on the rear of the unit. So you're going to have dual busbar connections for positive and negative. You're also going to have an RS-45 connection port and a CAN port. And then you're going to have a link in and link out port, which allow communication from each battery in the stack. The batteries will also have a screen on the front, which is going to provide you with state of charge information, temperature, current, and status. So you'll see whether or not the battery is in run, you'll see whether or not it's charging or discharging, and also any error indications, and that will be directly in the front. On the side of the unit, there will also be a side-mounted output breaker, and that allows you the flexibility of being able to turn off these units independently, but also to ensure safety when you're installing. So through the installation process, you would ensure that those breakers are off. However, you can turn the unit on or the BMS on the unit on to be able to verify the state of charge information on that battery before you install. The reason why we've done this is to allow, in the case of an installer, to be able to check those units and to ensure that the units are going to be balanced before you take them on site for an installation. And just as an example, if you were doing an installation that may be in a remote application, and you want to ensure that all of the components are ready to go to be able to do that install, you can verify that state of charge and voltage on each battery before you take them on site by simply taking them out of the box, powering on the BMS switch, and then you can see right away what the state of charge is for each unit. So the stackable comes essentially in two different SKUs. So the battery itself will be one SKU, and then there's going to be one SKU which will be the base and top assembly for this. The base is going to have four casters as well as leveling legs, and so essentially that component is going to provide you with the connectivity cables to connect to your inverter and also some ground cables and some other components that are necessary for assembly of the stack. When you're assembling the stack, each one of these units will also have a back panel. So that back panel is going to be placed on after the cable connections, the terminal connections, and any communication and ground connections are completed. And then the back panel essentially covers all of those connections. You'll note on the back that it looks like it has a handle cut out. That actually is a dual purpose. So it does allow you to remove that panel if you need to, but it also provides visibility for the UL, in our case, Intertech logo. That is a requirement for UL 9540 that all of those certifications need to be accessible and they need to be visible for inspection. So once that system is installed and you've stacked those units and placed that back panel on, then it also comes with an anti-tilt bracket that can be mounted to the wall, and it can be either mounted at the rear of the stack or on one side of the stack, allowing you to secure it in place. All of the connections are going to run down through the bottom of the unit, as you can see on the right here. So essentially, it's a very streamlined application. There's no requirement for conduit in this case. And so any of those connections essentially can be run out through the bottom and then run out to your inverter, and so on. One thing that I will mention is that we are working on an additional accessory component, and that will be essentially what we're going to call a combiner box. This combiner box would fit at the top of the stack and would have conduit punchouts, as well as some other placement for other system components. One of the examples would be a Victron display screen and others. And so we're going to integrate that into that combiner box component to be able to offer the flexibility of being able to streamline and run conduit into the unit, but also to be able to house other components and some wiring as well. So when you receive those units, you're going to have those two SKUs. One is obviously with the battery, and then you're going to have another SKU, which is the base and top assembly. On the cartons, we've also included the packing list for each of those components, and that includes everything from the bus bar connections, the ground connections, and so on. And we've itemized all of that in a packing list directly on the carton. The reason why we've done that is so that you can verify that obviously all of the components are included in the box, but also to obviously be able to ensure that you have the current copy of the manual and so on. So one thing that I will mention, and this actually came up with a customer yesterday, the unit will come the pre-loaded by default to work with Victron Energy inverters. And the reason for that, during the development process, that's what we were using for testing purposes, and we essentially have to assign one inverter protocol to the unit. So out of the box, it will work directly with Victron Energy components. And then if you're going to be connecting it with a different inverter, then you'll go through the inverter protocol setup process to be able to assign the corresponding protocol. So on that unit, I mentioned before that there's a BMS switch that would allow you to be able to check the state of charge of the battery and potentially complete a balance on the batteries as needed. So on the rear of the unit, there's a small red button, power button, and so if you put that on, sorry, on the display in the front of each one of the units will come on. And what you're looking for is to ensure that the state of charge from battery to battery is within roughly 5%, ideally within 5 to percent state of charge, and then no more than 0.03 volts off. When you do connect these units, if you are taking them on site and you haven't completed that process, you do have the flexibility once it's assembled to be able to turn off the breakers to those units that don't need to be charged, and you can actually apply a charge independently to these units to be able to balance them as well. So when you're connecting the batteries, all of the components necessary for assembly will be included in those two boxes. You're going to receive two dual positive bus bars and negative bus bars. These are 200 amp rated bus bars. And once you assemble five of these units or more, you actually can do up to 400 amp charge and discharge current. So by using these dual bus bars that increase the charge and discharge capability on the stack, which is far exceeding most of the competitor offers, especially if you're using, a traditional Amphenol connector. You'll also, in the base and top assembly, get what we call a combiner plate. So you can see on the top here on the negative connections, basically it's joining those dual bus bar connections, and then you would connect your negative lead to the inverter on that negative bus bar. So when you're connecting the bus bars from unit to unit, it's important that you have them flush against the terminals. So there's an order in which that you would connect these bus bars, and depending on whether or not you're assembling an even number of units or odd number of units, the combination and the order of doing that is outlined in the manual. So you're going to start with either the combiner plate in front of or in behind the bus bars. I'll also note that when you're assembling these, based on the design, we recommend doing the positive combiner at the bottom and then the negative at the top, and that ensures that you have enough space to run your cabling through and down out the exit at the bottom to be able to run it to the inverter. So when you're assembling the stack, the primary battery will be the battery at the bottom of the stack. And so you need to assign using the dip switches on the rear of each one of the batteries to assign essentially the battery's position. So once the connections are made, you can go refer to the dip switch table, which is included in the manual, and set up the four dip switch code for that particular battery. So you're going to have from 1 up to 8, depending on how many you're stacking. And then that primary battery is going to be the one that's connected to the inverter. So whether you're connecting with the CAN bus port or the RS-45 port, then in either case, you're going to always connect that to the bottom battery in the stack. And then all of the corresponding batteries will be connected. So battery 2 will be the next one in the stack, and so on. And then the link in, link out port cable will be connected from battery to battery as you move up the stack. So on the front of the unit, I mentioned before that you would be able to see status information when you turn on the BMS switch. So once that unit is connected and the stack is assembled and connected to the inverter, in the case if you're doing a charge, for example, the status light on the front of the unit is going to change depending on the conditions. So if you're doing a charge or a discharge, and if you run into a situation where the BMS has triggered an alarm, then that's going to be indicated on the front of the unit. In the case of an alarm, as an example, if it's an overvoltage or overcurrent situation, and that's triggered, chances are the alarm is going to be shown on all of those units in the stack. However, if the alarm goes off on an independent one, then that's possibly due to an issue specific to that unit. So, but typically, if you're seeing a condition that's outside of the constraints that have been set by the BMS, then you would see all of the units showing that alarm. So when you do see an alarm, you have a couple of ways to be able to retrieve the information to determine what that specific alarm condition is. We have an LFP Connect app, which allows you to connect to the batteries via Bluetooth. And once you connect to those batteries, you can actually see a fault log for that battery, and it will record any incidents where the alarm has been triggered, and will save that information in a data log. So if you do run into a situation where the battery is triggering an alarm condition and it's being recorded, you can look at that through the LFP Connect app. You can see what that alarm is in reference to, and it could be something over temperature, under temperature, voltage, and so on. And if that does happen, then you can actually see that there is an alarm log, and you can actually retrieve that information, save it. You can open it on your phone if you wish, or you can actually submit that directly to our tech support team. So within the app, you can set up a support ticket and you can attach that alarm log directly to the support ticket, and then we can open it up and identify what the issue is. If it's a condition where the battery is, attempting to operate in temperatures which kind of exceed the constraints that have been preset by the BMS, then that's going to be recorded, and it's going to be noted that, there was an attempt to make, a charge on the battery and it was below, the temperature constraints. So in those conditions, that will be logged. The batteries do not log all conditions all the time. So, under normal operation, it's not going to be recording information and as a log. It's only going to be in the state of an alarm condition. So when you're connecting these units, what we've done in the manual is divided up the inverters into essentially two different lists based on the capability with reference to closed loop communication and the information that's shared. So the first list is essentially offering full support. So one thing that happens with the ESS units, and it's very standard across most of these, the BMS is capable of sharing information related to battery voltage, temperature, cell temperature, and so on. But in some cases, the inverters may or may not use that information and retrieve it and share that, whether it's on screen or through a remote application or whatever. And so what we've done is, going through the testing process, we've identified, based on the protocol that has been set, and whether or not that particular unit shares that information with the customers through the inverter. So this particular list will provide you the protocol that's associated with that particular brand of inverter. And so that particular protocol would be selected within, whether you assign the protocol through the LFP Connect app or you do it through the PC software. You're essentially going to pick that particular protocol that's listed in the table. And then once that's assigned to the battery, then it will be compatible to connect and to be able to share that status information with the inverter. So in the case of full support, these units would also report any of those alarm indications. So in the case where the battery has, an alarm triggered and it's a condition, say over temperature, for example, it's going to relay that information through closed loop communication to the inverter, and these particular units will actually share that information. It may be on screen, it could be through, other notification, but it's essentially going to be shared through the inverter. In the case of basic support, the condition of communication is still there. However, in some cases, the alarm conditions may or may not be shared, and that depends on the particular models and so on. But we've kind of broken it out to set that expectation. When you are connecting to the unit and setting up the protocol, in some cases there may be a particular protocol listed, and with, for example, the protocol may be listed with RS-485 type connection or with CAN. So it's important that you pick the appropriate one based on the particular inverter that you're working with and what that inverter requires. So when you're setting up the protocol, there are two different ways to do this. What we initially had was essentially a PC software where you load the software onto your computer. You use a cable, which is an RS-485 to USB cable, which is supplied in one of the boxes. And that actually allows you to connect to that primary battery in this stack. And then you can actually apply the inverter protocol that you wish to, set up. So for example, if you're setting up with LuxPower, you would pick that from the dropdown, write it to the battery, and then you can verify that it has been written to the battery once that's been done. When you're using that particular software, you're going to see, whoops, sorry, I skipped. You're going to see a dashboard that looks like this. And essentially what that's going to provide you is cell by cell information. It's going to show you the battery status and state of charge. It's going to show whether or not it's under charge or discharge. And in the case where you have multiple units set up in the stack, you can click module 1, 2, 3, 4, and so on, and you'll be able to see independent information for each battery. When you're setting up the protocol, you're going to pick the inverter protocol setting tab at the top. And then from here, you would pick whether you're setting up RS-45 or CAN communication. You just essentially pick the appropriate protocol from the list, hit write, and then it will write that directly to that battery. Now, in the stack, only the primary battery needs to be assigned the protocol. So essentially, if you've got a stack of 3 or 4 or 5 of these units, then you're not going to have to apply that protocol to each battery in the stack. You only need to do it to the one battery that's connected to the inverter. So to do that, each one of the batteries is going to have a Bluetooth address sticker, and that's going to essentially identify that unique battery. So when you're stacking these and you're assigning the protocol, you would, in this case, connect it to the primary battery, and that would assign that only specifically to that battery. But in the case of using the Connect app, you'll have access to be able to connect to any one of the batteries in the stack. So in the case, let's say, for example, you had 4 batteries and you were connecting and you wanted to assign the protocol. When you search for batteries within the app, it's going to show you the Bluetooth address for all of those. So what you would want to do is look at the sticker for that primary battery and then select that particular battery from the list of batteries that are available to connect to. And then once you connect to that battery, then you can select the appropriate protocol from the drop-down list, and it's very similar to the PC software, and then write it, and you'll see a status essentially go through where it's sending the information, and then you'll get a confirmation that that has been written to the battery. If you, for some reason, set up a system and you disassemble, or take that system out, and then you want to reassemble it, and you're not sure which battery was assigned the protocol, you can actually connect to the batteries, and then you can actually check and verify what protocol is assigned to each battery by just connecting to it and then doing the check protocol setting. If you want, you can also assign the protocol to all of the units in the case where you may want to have the flexibility of being able to rearrange or reassemble them and not have to worry about it. One thing to note though is that if you do reassemble the batteries in stack again, you would need to reset the dip switches according to battery 1, 2, 3, and 4 in the order of the stack. So whether the protocol is assigned to it or not, you would still have to complete that step in order for the batteries to be connected properly. So one thing that you also need to consider when you're setting these up with a particular inverter is going to be the current limits for the stack based on the number of batteries that you're connecting. So I mentioned before that the bus bars are dual bus bar allowing up to 400 amps of charge and discharge current. But one thing that we also need to look at is the current limit of the batteries based on the BMS. And so in the installation guide, at the beginning of each one of the sections, depending on which inverter you're connecting with, we've outlined what the minimum number of batteries would be for that particular stack. So in this case, the SNA 6K inverter, the minimum would be 3 units. So for each one of those units, it's 100 amp hour. So in this case, you would have to go to a minimum of 3 modules in the stack to be able to connect to that size inverter. If you're going with a larger, like 12K inverter, then you would have to have a minimum of four in that stack. And so we've outlined that at the beginning of the setup guides for each one of the inverters, to basically give you kind of a heads up that if you do connect a smaller stack with that larger inverter, the peak discharge or potentially the continuous charge and discharge may exceed the capability of the BMS. And so it would actually trigger the BMS in those units just to shut off. So in that case, the it would log it as an error, but ultimately the system will go down because it is undersized on the storage side to work with that particular inverter. So connecting, and this I'll just run through kind of the examples that we've outlined. We have gone through, we've added some photos of these particular units, and what we've done is selected sample models that are offered through Charge to ensure that obviously you have some familiarity with the setup, but also to ensure that we have done the testing and the integration testing that's necessary to be able to make sure that obviously the communication and the error codes are going to be reported. So all of that is done internally. So what we've done is built essentially a step-by-step guide, which will walk you through the programming of that particular equipment. One thing I will note is that obviously, as they apply firmware updates to the equipment, it's possible that some of the menu may change. And so in those cases, we will make every attempt to try to update those, but it's possible that these could potentially become outdated. In that case, we would welcome your feedback and we will certainly address that. We do work very closely with the inverter manufacturers to get that documentation and to complete testing. So in most cases, they're reporting that to us anyway. So in the case of the LuxPower LXP series, you're going to be connecting the batteries to the RS-45 connection on the battery module 1. And out of the box, there is an RJ45 communication cable that's supplied. It comes with the base and top assembly, and that's your communication cable to the inverter. Now, it's a straight through cable, and that generally will work with a variety of different inverters. However, there are some brands that use a cable which is at a different pinout configuration than what is, generally supplied in a straight through cable. So what we've done is outlined in the manual, essentially, here's a heads up. If you plug that communication cable in, it's likely that it's not going to work properly because the cable needs to be reconfigured and the wiring realigned. So what we've done is outlined, this is what is necessary for that particular product line. And we've also included new RJ45 connections to allow you to be able to snip the cable and realign them. So going through the inverter setup, we've walked through essentially the setup of a stack, what battery selection would be set. With these particular units, you're going to have a voltage range that you can set, much like a traditional deep cycle battery, depending on the conditions, you may or may not have, particular voltage setting. But we've walked through the setup through the menus on those particular models to essentially give you, an indication of what should be set to work and to be compatible with a stack, whether it's 1 unit or up to 8 units. So throughout this manual, the documentation is going to provide you the screenshots. It's going to explain to you which battery type to select from the menus. And we've worked with the inverter manufacturers to identify, what would be the best settings that they work with. They have also used our batteries in testing internally as well to verify that these settings are correct. So the guide that's provided, which is printed and included with the base and top assembly, will give you all of those settings as a walkthrough. So you're going to set up things, the state of charge, the battery current limit is going to be set as well. It's important that you set that so that you're not exceeding the limit on the stack based on the particular number of modules that you're assembling. And then any of the other settings related that would be outside of charge and discharge on the battery, outside of that offered within the inverter would you would need to refer to the inverter manual on. So we've essentially just covered the basics as far as communication, charge and discharge, and any required settings. One thing that we did note through this process in setting up these was that a lot of the units have a pre-programmed like LFP setting, for example, which in some cases will align with the charge requirements for our stackable, but in some cases you will need to tweak it. So we've outlined that at the beginning of the guide, mentioning that, the bulk of the settings that are programmed under that profile will work. However, we recommend making these, small adjustments. And so the voltage for absorption, you're going to set that at 57. In the case of float voltage, for those of you who've worked with lead acid in the past, generally you'd have a float that would be slightly lower than your charge voltage. In this case, you're just going to set it at 57 as well. So you're walking through those voltage settings, and then once you complete that, you're going to see on the screen that closed loop communication has been established. And so you're going to see right away that that communication has been set up correctly. If you have, we've included this in the manual as well, any other charge discharge parameters, grid charge, time of use, things like that, all of those settings will be outside of this guide. So that's kind of at your preference and how you set that up. And then walking through, we explained where the terminal connections were, which one of the ports is going to be set up for communication. In some cases, they may not be clearly marked on the inverter, and we did notice that as well. So we wanted to identify, this is a particular port that you want to connect to. And then in the event that you do run into a problem, when you are connecting to the inverter, if there is a problem, you're likely going to see an error indication about communication on the inverter in some way, whether it's displayed on the screen or some alarm of some sort. And that generally is going to be caused by a condition that's probably, connected into the CAN port instead of the RS-45, or potentially you need to readjust the wiring for that COM cable to align with the particular inverter that you're working with. So in the case of the SNA series, these units will provide you an alarm. And so the alarm is actually going to be displayed at the bottom. Yesterday, I had an individual who contacted us who had connected one of these units, not knowing that it was programmed to work with Victron, and connected it, and then right away, they had an alarm code of 00. And so what we've identified and put into the manual is essentially, an explanation of what some of those codes are, and explained that, in those conditions, it is a communication problem. Check the cabling, ensure you've connected in the proper ports, but also ensure that the protocol is written. So it is very easy to identify the issue and to be able to change that. So again, walking through those steps, setting up the inverter protocol, making some tweaking on the settings based on the particular install. Certainly, that's going to happen with most installations. So these are going to provide you, general guidelines to ensure that it's going to be properly charging and discharging, and within the conditions of the BMS. And then, again, if there are any particular settings outside of those, then those settings would not be included in this installation guide. One thing, again, just whether you're working with the LXP or the SNA series, is it's very important that you set those current limits in the unit to ensure that it's not going to trigger the BMS to shut down because of overcurrent, especially if you're running less than 5 units in the stack. So I'm just kind of walking through some of these other settings, just kind of give you an indication. If for those of you who worked with this equipment, you're probably very familiar with the menu options. What we've essentially done is gone through from start to finish how you would go about programming it to work with that particular unit. So very, very straightforward. In the event that you see, any other options or some of this information is changed on the screen, we would really welcome the feedback to be able to update that because we have found through the process there's been a few firmware updates that have been made even over the last year that we've had to reflect and change in the documentation. And again, some other settings for those of you that have worked with, lead acid, sorry, whether it's flooded or AGM, oftentimes you would have a discharge cutoff voltage. You're still going to program that. Now, the BMS will actually shut the system down based on low voltage, but we recommend setting that at 47. That's just to ensure that it's obviously triggering that before the BMS has to do that. One thing to note, with most LFP products, the battery management system, the BMS, is essentially controlling charge and discharge to the battery, but it's also managing balance and so on. And the more that BMS has to work to try to correct for conditions that are not, optimal, then it's more likely to wear down the BMS and potentially run into a situation where the BMS needs to be repaired or replaced. In those conditions, the system has been designed with the back panel with all of the connections on it, but that back panel on the stackable unit is designed to be removable. And the BMS is actually mounted directly on the back of that panel, which makes it very, very easy to service as well. So part of the design of the stackable, looking at the breaker on the exterior, the separate BMS switch, and also the design of how to be able to access and maintain the product was very important because we know, obviously, working with batteries and especially with installers that are working with customers that could potentially be off grid, time is of the essence. So we want to make sure that these can be addressed and repaired and changed out, if components need to be changed very easily. The BMS is more likely to be worn down in conditions where it's constantly having to correct for voltage conditions that are slightly too high or at the limit. And so in those situations, you will see the condition of the BMS would wear down much quicker than the cells. So this is essentially, again, just walking through those settings, setting up your charge. Also, any other conditions that you may be setting up for, time of use, so on. All of those we've outlined, generally where those would be set, but we haven't gone into detail on that side because that would be kind of at the discretion of the installer on, how they want to set that up. Again, looking at Sol-Ark, for example, we've outlined various units and then the number of stackable units that would be required based on that particular, size of that inverter. And Sol-Ark is one of the inverter manufacturers where the straight through cable that's supplied will not work with their particular products. So what we've done is we've provided essentially a pinout that will show you what the order is for the cabling. And then again, as I mentioned, you will have some extra components that you can actually snip the wire and then realign that. They don't include a cable with the inverter that is directly compatible. The cable that they provide won't work on the battery side. So you essentially have to build an appropriate cable to be able to do that. Once that's connected, then you'll see visually on the Sol-Ark equipment, once closed loop communication has been established, then you'll know right away that has been set up properly because it'll be displayed on the screen. You can also verify that by looking if you do connect the PC software and then connect to that primary battery, you'll be able to see whether or not that communication has been set as well. The information on the LFP Connect app is very convenient to be able to do it directly on your phone via Bluetooth, but there's going to be some limitations in the amount of detail that's provided through the app, whereas you'll get far more detail through the PC software. So, we walked through essentially the same steps with Sol-Ark equipment, explaining what the battery type should be set at, battery percentage, and so on, and walk you through those menu options from start to finish. And then once that is done, then you should have the system set up in closed loop communication. So these settings, one thing that obviously is very important is to ensure that you're setting that shutdown, low voltage, and so on. These conditions are what we have recommended in the system. You may, in some cases, want to set these higher depending on the particular application, or depending on, how you choose to set up the system. But we would not recommend going below those percentages just because it's most likely going to trigger a BMS condition to shut down the units. So the off-grid, there's a couple notes here regarding low battery and restart. So one thing to consider with the LFP products, if you're switching from a lead product, for example, and doing a retrofit on a system, the state of charge of the batteries, depending on, the storage of the units and so on, is going to be very different than what you would see with traditional lead batteries. So traditionally, if it's a seasonal property, the recommendation has always been fully charge the units and then disconnect the system. In this case, you don't necessarily need to disconnect, but you do want to ensure that the batteries are maintained at an adequate voltage. And then in the case where it does go down to a low voltage, this unit is actually designed, the BMS is actually designed to go into what we call sleep mode. And so it's actually going to do that to prevent it from fully discharging the battery. So what will happen is it's going to shut down, but it's still going to allow an adequate voltage to be able to power on and to be able to give you a voltage indication on the inverter. So for those of you who've worked with lead in the past, if you have a system that fully discharged, you try to turn the inverter on, you're not getting any power at all, so the inverter won't get triggered on. So you have to charge the batteries independently and then reconnect them. In this case, you're not going to have to do that. So the battery is going to wake up, and then you're going to have a voltage reading that's going to be adequate to be able to power on the system and charge again. So again, walking through that communication protocol, once that has been set properly, so you're selected, in this case, Sol-Ark from the dropdown, assign the protocol, and you've completed that cable realignment and connected, then you're going to see this information displayed on the Sol-Ark display. And so under the uh, lithium battery info page, you'll be able to see the current of the battery temperature information. As soon as you know that you see status information like temperature, state of charge, then you know that system has been connected properly. So I mentioned before that the LFP Connect app will give you some connectivity to obviously the batteries by Bluetooth, and it also gives you access to support. So one thing that we've done with the app is built in some essentially offline availability of resources. So the support page on our website offers a number of different articles and troubleshooting steps and things like that to help installers with setting up systems. But oftentimes, you may be in a situation where you're installing systems in a location that you don't have cell service. And in those conditions, what you would want, obviously, is to have documentation available. So what we've done is we've built in some of the primary documentation directly into the app, so you have an offline access to that. You also have access to be able to search within the articles related specifically to lithium products and to be able to look for troubleshooting information specific to those. And then if you have a particular question related to, that particular product, or you want, run into a situation, as I mentioned before, with a log, then you can actually connect to the battery, attach the log, and submit a ticket. By doing it through the app, when you set up the app, you'll have the option of choosing installer mode, and that allows you to put in your contact information, but you also can organize your installs and have, for example, customer A, you can put in their name, their address, and so on, the customer information. And then if you want to file a ticket for that, particular install, then you can share that in a ticket and it will automatically be shared with us so that we can keep track if you have multiple installs and you want to, ask questions about them. But it also allows you to manage and to keep track of the log files for each of those units. So within the app, you'll have the option of adding a location. You can name that location. You can include photos of the install as well. So if you want to take photos of the physical install, you can take photos of the menu options and what you have programmed in the system. So you don't have to go back on site to look at it again. So we wanted to build some of those features in to essentially give you, access to be able to log a lot more information, but also to have the flexibility of being able to, quickly look and see what settings have been set up. And if you need to contact us for troubleshooting, then you have access to that information. Another feature, which is going to be launched next week, is the ability for you to log essentially your service time for an install. So, from an installer perspective, under installer mode, if you're doing a site visit for a customer, you can record that site visit by date. You can put in the duration of the time you were there or the time, when you arrived and left. You can document any information, any changes that you made to the system settings. All of that can be logged and then saved within that location. And you can save those locations indefinitely, or you can pull that information out and share it for your own purposes if you wish. But we built that in for installers to be able to keep track, but also to be able to share those logs. So if you run into a situation where the system is shutting off for some reason and you have an issue, you can share the logs of what the conditions were and any changes that were made, and then we can have a look at that and help you out with it. The last thing I just want to mention is the product registration. So the stackable units come with a standard 7-year warranty, and that's going to cover all the components. If you're connecting with one of the hybrid inverters and setting up closed loop communication, then if you register the products and set up the product registration, which you can do through our website or also through the app, then you'll get an additional 3 years of warranty. So you're essentially getting 10 years in total, but it's also a performance warranty. So it's going to guarantee the performance and state of charge of the cells for that full 10-year period. So when you're submitting a registration, if you have questions, related to the form, you can contact us. We can walk you through it. You can also submit the information that you do have, and then if there's any information missing, we'll respond back to you and walk you through the process to ensure that we get everything necessary to complete that registration for the customer. Customers can do the registration as well, but for the most part, it's essentially going to be installers doing that. And we're happy to work through that process. The registration needs to be set up and started within 30 days of the install, and that's highlighted in the manual and outlined during the setup process. And you very easily can connect and do that registration through the app on site as well. So it's tried to make it as easy as possible. Again, within that app, you will, or through the website, you're going to have access to our product support as well. So if you have, a question about the product from a sales perspective, or you've run into a particular troubleshooting issue and it's not outlined in the documentation, then we're happy to walk through that with you and, answer any questions that you have. We also, as well, this is a fairly new product, so we welcome any feedback on the product from the assembly process, setting up the protocols, any of the feedback related to the app, and as well through the support portal. So we certainly, we're designing these to work, essentially for installers, and adding those features in with you in mind. And so we want to make sure that we're doing that and are adding to that based on your feedback. So we do have some time for questions. If anyone has any particular questions about specific inverters, then we can walk through that as well. But hopefully that was providing you enough overview to explain how to go about setting up the system and setting up communication.
Awesome. Thank you so much, Jeff. I don't see any questions in the Q&A right now, but we'll give it a few minutes for people to type those in. But Jeff, thank you for joining us today and for your very detailed and informative presentation. I'm also just going to pop our YouTube channel into the chat for everyone here because this recording will be live on our YouTube channel later today, but we'll also email you the recording of this webinar as well. There we are in the chat. And let's see, still no questions. Oh, here's one. We just got one. Can you provide a single line diagram of how to install the battery?
Single line. So within the manual, so you're going to have two different documents that are provided. One is going to be a battery operating manual, which is included with the battery in the box. And that's essentially going to give you kind of the overview of the features of the product, how it's connected, and how to do essentially the protocol setup. It's going to explain that. The second document is the one that's going to be far more detailed. It's going to provide you the step-by-step assembly of the stack from 1 up to 8 units. And that is all done with line diagrams. So the documentation will provide you essentially starting off with the base. You're setting up the first unit. There are two screws that are provided. One is going to be, they're essentially put in on each side of where the handle is on the side of each one of the modules. And you're just going to essentially screw that into the base, and then the corresponding battery is going to screw into the next one and so on. So it's very, very simple to install. Once those batteries are assembled in a stack, then you would start with your terminal connections. So the bus bars that are provided are going to be obviously sized to go from one battery to the next. You're also going to have ground cables that are supplied. So on the base of the unit, there are going to be two spots for ground connections. One of those is going to connect to your ground, your main ground, and then you're going to have the other will be connected to the first battery in the stack. So each of the batteries are going to have two spots to mount a ground connection. One is on the lower is going to be connected to either the battery below it or to the base. And then the one on the top is going to be connected to the battery and the next battery in the stack. They're all obviously sized appropriately to complete those connections. And basically, you're just going to follow that process as you move up the stack. There's also a ground cable that's going to connect from the top battery in the stack to the cover. So all of the unit has to be grounded, and that includes the top of the assembly as well. So that you're going to have a ground cable that's included for that. The steps in the manual, the installation guide, are going to outline essentially from start to finish, depending on the number of units you're connecting. And then once the terminal connections and the ground connections are done, then you would start with the communication. You can connect all of the link in, link out cables from one battery to the next, and then connect your inverter cable and then set up the protocol. But one thing that you can do is assign that protocol to the battery ahead of time before you even take it on site for the install, and that will save you some time. But also, it's not required to have the cable obviously connected unless you're doing it with the PC software. So it's essentially very straightforward as far as the assembly. There is a document on our support page as well, which was essentially a section of the installation guide, which outlines the physical assembly of the stack and how to go about doing that. And there's some diagrams in that as well, which we can refer to. Rolls Battery, just click on support on the website, and that's the quickest way to be able to access those.
Wonderful. Um, we have one more comment here. Somebody was just asking where they can see one of these units. They live in Calgary. Come to Charge Solar Calgary to check one of these out. Yeah.
Yeah. So I believe they have them in stock. I know they have them in stock in Barrie. I believe there's some in Calgary as well, and I believe in Dartmouth they have it. Yeah.
All right. Maybe we'll give it another 30 seconds for any last minute questions. Nothing there. Well, Jeff, thanks again for joining us today. And like I said, this recording of the webinar will be sent to all the attendees on the call today by the end of the day. Thank
Excellent.
you so much.
Thank you very much, everyone.